Hello everyone, it's Ayush Bhatt this side, and I'm with my group mate Dev Patel, and we are here to present the project on LLM, that is large language models, and our topic is sentiment analysis. So moving ahead, this is the agenda, basically table of contents. First one will be the introduction, then sentiment analysis, the project workflow, then tokenization, model fine tuning, model evaluation, testing the model, and then the future aspects of the models or the project basically. So yeah, sentiment analysis. So we'll cover three aspects of it, like what is sentiment analysis, importance in NLP applications, and then the common use cases of it. So we basically know that sentiment analysis is used to determine the sentiment behind a piece of text, basically to identify whether a text is expressing a positive, negative, or a neutral sentiment. So yeah, I mean, and this ability to analyze the sentiment is basically crucial in various fields. And common use cases here are like analyzing customer feedback, monitoring brand sentiment on social media, as well as gauging public opinion in political campaigns and whatnot. I can go on and on, but these are just common use cases that we know. Moving ahead, yeah, so the project workflow. First point was the environment setup. Second was to load and pre-process the IMDb dataset. So basically, we use an IMDb dataset in here. Then we tokenized, so basically tokenization using BERT tokenizer, then fine tuning the BERT model, and then at the very end, evaluating and testing the model's performance. So yeah, we first of all loaded and pre-processed the IMDb dataset, which basically contains the movie reviews labeled as either positive or negative. And then we apply the BERT tokenizer to convert these reviews into a format that basically our model can understand. Simple. Then we just fine tune the pre-trained BERT model on that specific data set. That's it. So yeah, so moving ahead, tokenization. And we know that tokenization is a pretty vital step whilst preparing the text data for every machine learning model. And specifically for this project, we have used the BERT tokenizer, which is specifically designed to work with BERT models, obviously. So yeah, I mean, the tokenizer converts each piece of the text into a series of tokens or basically numeric representations which the model can process. And since BERT expects inputs data to have a consistent length, we have even applied padding and truncation to during the tokenization steps. Now, basically, padding will add zeros to short the sequences to reach the required length, while truncation cuts the longer sequences down to specific sizes. So that's how we process the data in here to get the consistent input lengths. So now moving ahead with the model fine tuning, we fine tuned a pre-trained BERT model, as I said on our dataset, where we have even used BERT base uncased model, which is very commonly used. This is a very common used version of BERT. And then fine tuning involved taking a model where, I mean, which has been already trained on a large corpus of text and then adapting it to a specific task. In this case, which was sentiment analysis. And now we've even set a learning rate of 2e minus 5, basically, on which we trained the model for 3 epochs, where the batch size was 8. And then these parameters were chosen to just balance the training efficiency as well as modern performances. So basically, all of this, the fine tuning process, allowed the model to learn the nuances of the sentiment in a data set and then leading to improved accuracy in predicting the sentiment of the new text. Now, giving it over to my teammate Dev Patel. So he'll move on with the next topic, that is model evaluation.
Hey guys, my name is Dev Patel, and as my colleague already said about the model and fine tuning, so basically I am gonna present from the model evaluation uh, for the sentiment analysis for the natural language processing. So what happened in the evaluation matrix, the accuracy, the proportion of the correct predictions, and we need to find the loss and results. The loss is the error and the model predictions, and the result is summarize the model performance on the test set. Basically, accuracy measures the proportion of the correct prediction made by the model, And while the losses quantifies the error in the model prediction, which lowers loss and values higher accuracy, indicates better performance. So we are going to move to the next part, which is the last part of the testing the model, and we need to upload the model after testing in the real world applications. So we need to test the model to for the real world application. So for that we have the example input like this: the movie was fantastic. So sentiment analysis works on that basis that it should be generate and the sentiment which is positive or the negative based on the based on the text which we are provided to the model. Like the model output was the positive sentiment prediction because the movie was already fantastic. The significance of that, they demonstrate the model's ability to generalize the new data, and by testing the model on the data that it hasn't seen before, and we can determine how well it generalized to the new unseen data. As we already said before, regarding the model testing part and the model evaluation and the fine tuning set. And so at last in our case, the model demonstrated the strong performance accurately and predicting the sentiment of the test set and with the high degree of accuracy and low loss. Yeah, for the future work, we already have said that the explore multilingual sentiment analysis and extend the model's capability to handle the sentiment analysis in multiple languages, like, and to fine-tune models like the AMBERT or the XLMR for the multilingual applications that are the amazing models which generates the excellent sentiment analysis results. And if I talk about the integrate contextual understanding, so model implement the techniques like to enable the model understanding the context pattern and the leading to more accurate sentiment predictions in as well as the complex scenarios. And the other thing is user transform based models with extended context windows. And the last thing is expand the applications to other NLP tasks. Like we need to handle the emotional detections, the text classifications, or opinion summarizations like that task. And the last thing is explore the versatility of the fine-tuned model in broader NLP applications for the future purpose. So that's all for today. Thank you.